Hi, welcome back to our day 2 recap. So last night after we finished our prototypes, we went to the drawing table and tried to figure out how we were going to fit everything onto our robot, and we started CADing it out. And so all day today we've been just trying to get the robot built as fast as possible. So far what we've got done is the bar intake that we were talking about yesterday. So this thing flips all the way out. It extends about 10 inches past the frame. So for the roller bar, we have 2 omnis on either side of 2 4-inch compliance wheels. So the reasoning for that, the compliance wheels are obviously gonna pull, they're very grippy, so they're gonna pull the ball straight in. From each side, we're gonna have 6 inches of bumper. So these wheels are obviously not gonna be able to pull the ball straight in. So the idea is of having the omni wheels on the outside so we can at least pull the ball straight against the bumper, and we'll be able to kind of turn the robot, and the ball will be able to move side to side until it hits the compliance wheels in order to suck it into the center. So this intake is powered by a red line with a versaplanetary gearbox that is set up as a 5-to-1, and then we have chain going to the actual axle. We have a 16-tooth sprocket going to a 22-tooth sprocket. So for the intake, as you can see, it's sticking out, and like I said, it sticks about 10 inches outside of the frame perimeter. So for our starting configuration, it obviously has to be all the way in. So the way we're going to do that is we're going to hook up a pneumatic cylinder to either side. We might end up just doing one if it's strong enough. And it'll be one that's low here to the chassis that can push it all the way up. And so we'll hold it here at the beginning of the match, and then we'd deploy the wheels during the match and maybe bring them back in just at the end whenever we're doing the climb. For the chassis, we have an 8-wheel tank drive. We're missing 2 of the wheels right now just because of the work we're doing on it. It's a West Coast drivetrain, so we can easily adjust the tensioning on the chain, and we have 2 sims running it. The other thing we worked on a lot today is the ratcheting mechanism, or our winch system. So we went to the hardware store and just bought some ratchet strap. It's rated for like 500 pounds. And so we actually just took apart the ratchet itself too, and attached it to some hex shafts to be our winch mechanism. We have not yet tested it for actually holding the entire robot, but since this is rated for 500 pounds, we assume it will be able to do just fine holding the robot up. So it's pretty simple. Since it was already made for this, we can easily turn it as we're climbing, and then whenever we need to release it, there's just a little latch right here we pull down on, and we can pull it out. So powering this climber, we have parts that were all provided by AndyMark, and we have 2 red lines that are connected with a dual motor input, which has a gear reduction of 3.25 to 1. And then we have it hooked up to a sport motor planetary gearbox that is geared at 100 to 1. So overall, we have a reduction of 325 to 1 for the climber. We also have the multi-mounts on the back of this, and this entire thing was graciously provided by AndyMark. So the other thing we worked on today was doing the actual elevator that we talked about yesterday. So we just made it at a bigger scale using 80/20, and it's going to go somewhere at the back of this robot in order to lift up the hook all the way up to the generator switch. And once it hooks on, this winch system at the back of the robot is what's going to take over to actually do the heavy lifting to get us off the ground. So the other part of the climber that we made today is the actual hook. So this is really just a whole bunch of aluminum brackets that were hooked together in kind of a J shape in order to hook on, and we put some kind of rubber material just so that we'll hopefully slip a little less once we latch on. So this is kind of our backup plan. What we're gonna try and make work is this mechanism so that we can go, as we go onto the bar, this kind of slides under, and we have some surgical tubing right here so that we push it, it pushes out, and once we're in, it comes back up. and it's stopped by a little bolt right here from coming back out. So this would be the ideal design if we can get it to work and actually hold our weight. But in case this does not work, we're gonna stick with the J-hook. Our goal for the rest of the night is to finish assembling our actual shooter. So it's gonna go somewhere around here with a ramp coming up from the frame perimeter so that the balls can come straight into it. And so in order to hold more than one ball, since you're allowed 5 balls, we're going to have a hopper straight behind it. So it'll actually load it straight up into this hopper. That's gonna be the tube that we kind of showed yesterday at the end of the video. And it's just gonna, whenever we're ready to shoot, this is just gonna be able to angle up and it'll be gravity fed back up into it. So that's all we have for you guys tonight. Check back in tomorrow when we'll hopefully have a completely built robot and we'll be working on programming it then.